Hi there, this is Penelope. This is the first video in a series of 3 short videos on planes and lines and intersecting lines in the context of vectors. So for the first question here in this video, we're going to find the point where the plane meets a line. And what we've got there is the information about the plane and the line. And what we know, or what we should know, is that at the point of intersection, R must satisfy both of those statements. So if we set that out, and then dot 1, 1, 2 is equal to 3. So we've put the second equation, which is R, into the first equation. And then if we simplify all of that, then we get that 5 plus 5 lambda equals 3, from which we can see that lambda equals -2 over 5. And putting that back into the original statement, or actually minus, we get that R is equal to 2, 3 over 5, 1 over 5. So that is the point where that plane meets that line. In the second question, we are asked to find the equation of the line of intersection of 2 planes. So you've got 2 planes and they meet at a line. First of all, we need to write the equations into vector form. So the first one would be that, and the second one would be 4, 1, 2 equals 15. Now the required line is going to lie in both planes, so is going to be perpendicular to the vectors 1, 1, 1 and 4, 1, 2. So we need to find a vector, say C, doesn't matter what we call it, in the direction of that line. So this is where we use cross products. So C is going to be the cross product of the 2. Like that. This is where we use determinants, and we set it up with I, J and K because we've got 3 dimensions. And working out that, so it's I times 2 minus 1, which is 1, plus J times 4 minus 2, which is 2, and K, which is 1 minus 4, so minus 3K, which we could write as 1, 2, -3. Okay, just at this stage I can see I'm going to need another slide, so I'm just going to insert another slide. So I'm ready to move on to it. Okay. Now we need to find some x, y, and z values. And if we start off with trying x equals 0, and then we can find y and z. So that will give us that if x is 0, then y plus z equals 5. And from the second one over here, we'll find that y plus 2z equals 15. Solving those simultaneously will give us that y is equal to -5 and z equals 10. So now we've got a point. Remember that we said that x was just a value. So x is 0, -5 is y, and z is 10. That's a point lying on both planes. I'm going to run out of space. Lying on both planes. And you can check that by substituting into the original two equations. Now, we know that R is going to be something like this, but we've already found C. So C was what we had before, 1, 2, -3. So now we can say that R is equal to 0, -5, 10 plus something T times C like that. Now we could leave it like that, or we could put it into the Cartesian form, and the Cartesian form will say x over 1, x minus 0, equals y minus 5 over 2, which is equal to z minus 10 over -3. And we'll just tidy that up a little bit. So we've got x over 1 equals y plus 5 over 2 equals z minus 10 over -3. And you could leave it like that, or you could jiggle it around and find it in a straight line just by getting rid of your fractions. But as it is, that's fine.